Good day everyone. We are here to present to you our Capstone project proposal entitled Enhancing Soil Stabilization and Water Management, Integrating Segmental Retaining Walls with Geogrids and Road Drainage System at Poblacion Valencia City Diversion Road. The group 9 composed of 5 members, which are me, myself, Antonio Pascual Comendador, Devin Jasma, Nika Jean Dampios, Brian Dave Rajak, and Michael John Salave.
So, problem in the area. Landslides are more widespread than any other geological event and can occur anywhere in the world. They occur when large masses of soil, rocks, or debris move down a slope due to a natural phenomenon or human activity. Valencia City is one of the 54th landslide-prone areas identified by the Mines and Geosciences Bureau in the province. These landslide areas had been identified to experience moderate to high landslide occurrence, especially when rainfall goes abnormally high. The landslide in Bukidnon were caused by the rainy weather that triggered the soil erosion. The rains resulted in the erosion of soil into the provincial highway. Introduction. Landslide pose a growing concern in the Philippines due to its mountainous terrain, seismic activity, and heavy rainfall. The country faces significantly landslide risk with approximately 80% of its land area susceptible to landslide, ranking it fourth globally in terms of vulnerability. To address this issue, the integration of segmental retaining walls with geogrids has emerged as a promising approach, enhancing soil stability and strength while mitigating soil movement and structural failure. Geotechnical investigation becomes essential in ensuring safe and stable infrastructure design, facilitating the identification of suitable construction methods. Integrating segmental retaining walls with geogrids and a road drainage system offers multiple benefits, including improved soil stabilization, efficient water management, and cost-effective solutions. This study aims to explore the geotechnical engineering approach for enhancing soil stabilization and water management with sustainable infrastructure along Poblacion Valencia City Diversion Road. Proper water drainage systems are crucial for managing stormwater runoff and preventing flooding in the Philippines. On the other hand, poor drainage can lead to retaining wall failures and reduced performance of earth retention systems. By integrating segmental retaining walls with geogrid systems, road shoulder stability can be enhanced, mitigating soil erosion and structural damage.
So for our main title, we had Enhancing Soil Stabilization and Water Management, Integrating Segmental Retaining Walls with Geogrids and Road Drainage System at Poblacion Valencia City Diversion Road. For the objectives, for the design of segmental retaining walls, we have to assess the stability of slope areas, optimize the design parameters of retaining walls for slope and unstable areas in connection with the application of geogrids, and also for the geotechnical investigation for integrating geogrids. We have to examine and determine geotechnical properties of soil. Also, we have to determine the effective locations and patterns for integrating the geogrids and applying, and also for assessing their effectiveness if it is effective for our segmental retaining wall design. And so for the design of broad shoulder, for the integration of segmental retaining walls, we have to evaluate the significance of broad shoulders for the safety of the road travelers in Valencia City Diversion Road near the Barrio Valencia. Also, we have to examine the required road shoulder width in the design of segmental retaining walls and drainage system in case so for the safety. And also for the design of drain pipe to be used at a retaining wall, we have to comprehend the influence of inadequate drainage on the integrity of retaining walls, the potential leading to failures or compromised serviceability over time. Offer appropriate solutions to enhance the drainage system and prevent potential risk associated with poor drainage in earth retaining structures. Also, we have to examine the drainage design's performance and recommend improvements to ensure optimal water management. And so for the development of water drainage system aims to improve drainage system efficiency and prevent flooding by analyzing existing systems, identifying weakness, and proposing enhancement. And also, we have to seek to enhance groundwater recharge by developing methods to capture and infiltrate rainwater into the subsurface through structures like infiltration basins, permeable pavements, promoting controlled replacement of groundwater. So the significance of our study, it is significant to the community since this support enhances the efficiency of transportation networks and public amenities, benefiting the overall functioning of the community. And also for the environment, these walls help prevent land degradation, maintain soil health, and provide stability for infrastructure development. And also for the future researchers, it is a valuable guide for future research in this field. And also for the engineer and designers, it is easy to access to innovative and cost-effectiveness designs for road shoulder extensions and integrating retaining walls and efficient drainage.
So we have here the scope and limitations of our study. So the study aims to analyze and assess the soil properties of Diversion Road in Poblacion, Balasio City, Bukidnon, with a specific focus on evaluating slope, stability, and earth retention measures to support the planned construction of a segmental retaining wall, or what we call SRW. The investigation involves examining factors like reinforcement placement, soil characteristics, and load conditions. However, the findings and recommendations are limited to the specific site at Diversion Road. Moreover, the proposed measures for slope stability and earth retention will require additional evaluation and customization to suit the unique conditions and engineering considerations of each specific site. So now we have here the literary review of our capstone that could help us support in conducting the study. So we have soil classification and soil characteristics. Under this one is the site investigation, which is crucial for geotechnical projects to account for measurement errors and soil variability. And soil testing assesses soil suitability, bearing capacity, and potential impact on construction projects. Next, we have the geogrid stabilization. We have geosynthesis like geogrids enhance soil subgrade strength, improve bearing capacity, and offer economic stability. Combining gabion phase, geogrid reinforced retaining walls, and pile retaining structures optimizes slope stabilization. And geogrids significantly increase the bearing capacity of strip footings on slopes. Next review, we have the segmental retaining walls. So under this one, we have segmental retaining walls which stabilize soil and prevent overturning, tilting, and sliding. And gravity segmental retaining walls enhance stability with positive wall inclination angles, improving performance. Lastly, we have the segmental retaining walls are commonly used in stabilizing soil around bridges and embankments. Fourth review, we have retaining wall drainage system. Proper drainage behind retaining walls prevents wall failure and erosion. And maintainable drains are more reliable than traditional weep holes for promoting retaining wall drainage. And adequate drainage and consideration of water pressures in design are crucial for retaining wall stability. So fifth literary review we have from the water drainage system, where urban drainage systems in Metro Manila face limitation and need comprehensive planning for flood mitigation. Climate change impacts on water drainage require adaptation strategies for infrastructure design. Low impact development techniques like rain gardens promote sustainable drainage in urban areas. Integrated flood management strategies are crucial for effective drainage infrastructure. And for the last literary review that could help support our capstone, we have from the road shoulder management, which pave road shoulders enhance safety, reduce fatal crashes, and provide space for emergencies. Shoulder with impacts actual speed, lane position, and perceived safe driving speed, especially when a guardrail is present. And lane and shoulder widths influence road safety, with specific ranges considered safer for rural roads.
Hello everyone, this is the methodology of our study. In research design, we will use quantitative descriptive design. Our research locale centers around the diversion road in Poblacion, Valencia City, near Forten and Bridge, and Rivario, Valencia. To gather accurate and comprehensive data, we will utilize multiple methods. Site visits. It will allow us to assess the existing area and observe any issues that needed attention. Additionally, we will collaborate with the DPWH of Bukidnon 1st District Engineering Office to access relevant data. We will be collecting soil samples to analyze the soil properties and understand its behavior under different conditions. These samples will undergo laboratory testing to provide precise data of our study. Furthermore, we will conduct surveys to gather valuable insights from local communities of Poblacion and considering other literature studies. Our data analysis will be multifaceted and focuses on generating meaningful results. For accessing structural stability, we will employ finite element analysis, GIA5 software, and hydraulic analysis. These powerful tools will help us simulate various scenarios and evaluate the performance of the proposed infrastructure improvements. Descriptive and inferential statistics will play a crucial role in interpreting survey data and soil test results. These statistical methods will provide us with different insights into the challenges and opportunities present in the area of our study.
So this is our capstone work plan. So for the first site visit last week of June, the purpose is to identify the problem and assess the site requirements. The second site visit is second week of July, which is to finalize project site and gather additional data. So for the capstone proposal defense last week of July is to present and defend our well-structured proposal. For the first week of August, which is data gathering, so gather essential data from the Department of Public Works and Highways. For the soil testing, the second week of August is to assess soil properties to inform the project's technical aspect. The result and analysis last week of August to October is to thoroughly analyze collected data to derive meaningful insight. For the revision, November first week to second week, so is to address suggestion from the advisor and stakeholders. The final capstone defense is for the first week of December or second week, so to showcase our achievements and learning from the project. For the book binding, third week to last week of December is to assemble the final capstone report for submission. So the budgetary of the capstone, though in the first visit we used the total expenses of 600. For the second visit, so 450. So the capstone proposal defense is 600. For the data gathering, so it good for 3 days, so 2,700. For the soil collection, 350. For the soil testing, including the analysis fee, which is 1,500 each sample, so total of 8,200. So for the survey, which is 400. So for final capstone defense, which is including the printing and panel, so 9,000. For the book binding, for 30 pieces of book is equal to 15,000. So the total expenses for the capstone is equal to 37,300. So your presence and attention today is greatly appreciated. We are now open for the question and discussion you may have.